Okay, we're looking at 3.4. We're going to talk about two things that have to do with lines, and those are slope and the rate of change, which technically means the exact same thing. So when we talk about the slope of a line, first of all, just intuitively, what slope means is it means how fast the line rises or how fast the line falls. So it's like a speed, it's a rate of change. How fast does it happen? So by definition, slope is the change in the y over the change in the x. So the difference in the y's over the difference in the x's. So here are three different ways that we can think of slope. One way to think of slope would be rise over run, and we're going to use it in this way when we graph a line using the slope. So rise means going either up or down, and run means going either left or right. And if you think about it, rise means the change in the y's, remembering that the y's are vertical, and run means the change in the x's because the x's are horizontal. If you've taken chemistry, you'll recognize these symbols. Another way to think of slope is delta y. This is the Greek letter delta, and it means change in. So again, that just simply means, again, the change in the y's over the change in the x's. This is called the slope formula. And this is what we're going to use to be able to find the slope if you're given 2 points, those 2 points being x sub 1 comma y sub 1, or the x and the y of the first point, and then x sub 2 comma y sub 2, meaning the x and the y of the second point. So if you're given 2 points that lie in a line, you have this formula to be able to find the slope of that line. So, for example, here it says find the slope of the line that passes through the given point. So here's our 2 points. So if we call this one x1, y1, in other words, the x and the y of the first point, and call the second point x sub 2, y sub 2, we can find the slope by literally plugging into our slope formula. So the slope is going to be equal to y2, that's negative 2, minus y1 is 5, over x2 is 6, minus x1 is 2. So there I just plugged in my values. Now I'm just going to do the math. So negative 2 minus 5 is negative 7, over 6 minus 2 is 4. So the slope of the line is negative 7/4. We would never change that to negative 1 3/4. You would always want a slope to have a rise over a run. And by the way, because the slope is negative, it means that this line is going to fall to the right, like it's going down the mountain. All right, so let's do the same thing for B. So if this is x1 comma y1, and this is x2 comma y2, and we're just going to plug it into my formula, which says y2, so that's 3, minus y1 is negative 1, so watch your signs, over x2, which is negative 7, minus x1, which is negative 5. So again, watch your signs there. So 3 minus a negative 1 is actually 4, over negative 7 minus negative 5, minus a negative is plus a positive, so that's negative 2. Now this one, because it divides in evenly and gives me a whole number, I can divide that in. That means that the slope is negative 2. And again, because that slope is negative, it means that the line is going to fall to the right. So it's going to go down the mountain. Let's see what happens when we do C. So if I do x1, y1 for the first point and x2, y2 for the second point and plug it into my formula. So when I do y2 minus y1, that's going to give me 2 minus 2 on the top. And then if I do -5, that's x2 minus -3. That's going to give me a 0 on the top. And then -5 minus a -3 is +3. So that's going to be -2. And hopefully you remember that 0 divided by anything is 0. So this line would have a slope of 0. Now, if you think about it, if I were to graph these 2 points, I'm just going to sketch a graph. -3, 2 would be up there, and -5, 2 would be right there. It would be a horizontal line. So what you should now realize that the slope of any horizontal line is going to be 0. Now let's finally look at D. So again, using x1 and y1 for my first point and x2, y2 for my second point. And if I plug in my values to my slope formula, y2 is -8 minus -1. That's on the top. And look what happens in the denominator. You get 1 minus 1. So the difference in the y's on the top is -7. The difference in the x's is 0. Now you'll recognize that as an undefined fraction, because any zero that has or any fraction that has a 0 in the denominator is an undefined fraction. And you will write undefined, which means that the line that passes through those 2 points has an undefined slope. And if you graph those 2 points, you'll see that you would get a vertical line. So any vertical line has an undefined slope. Any horizontal line has a slope of 0. Any vertical line has a slope that's undefined. So let's look at number 2. It says find the slope of this line. But notice I give you a hint as to how we're going to do it. What we're going to do is we're going to find the intercepts, and that's what we did in 3.3. So if you quickly remember to find the x-intercept, you plug 0 in for y, and to find the y-intercept, you plug 0 in for x. So you should remember this from 3.3. So if I look at this equation, if I plug 0 in for y, this term cancels the -3y, and solving for x, I get x equals 2, because I would divide by 6. Doing the same type of thing here, if I plug 0 in for x, this is going to disappear, the 6x, and then dividing by -3, I get that y is equal to -4. So now I have my 2 points. So I can call the first one x1, y1, and I can first call the second one x2, y2, and I can go ahead and I can find the slope. So slope would be equal to y2 is -4 minus y1 is 0 over x2 is 0 minus x1 is 2. So doing the math, I get -4 over -2. Dividing, because it goes ahead and it goes in evenly, I get the slope of that line, which I have its name, is actually +2. And again, just in general, remembering that the slope, since it's positive, it means it's going to rise to the right, like it's going up the mountain. Okay, so there we've talked about slope. So we've already had the standard form of the line. Remember, the standard form of the line was ax plus by equals c. This line right here is in standard form. Another form of the line that we work with is called slope-intercept form of the line. And this is slope-intercept form of the line. Notice it's basically the line with the y alone on one side of the equal sign. So you solve the equation for y, and that will give you slope-intercept form. Now, m stands for the slope of the line, and your b is your y-intercept, or where the line crosses the y-axis. It's not your x-intercept, it's your y-intercept. And what we're going to be able to do is we're going to be able to graph a line. Now remember, the only way we have to graph a line right now is to make our XY chart. Now we're going to come up with other ways to graph a line. Oh, we also did intercepts, but that was still using points. Now we're going to graph the line from slope-intercept form by using the y-intercept and the slope. So we're going to practice that in number 3. So notice number 3 says find the slope and the y-intercept of the line by converting the line to slope-intercept form, and then we're going to graph it. Well, I hope we can agree that for A, it's already in slope-intercept form. The slope is 5/3, and the y-intercept is -3. So now, here's how you graph a line when you know the y-intercept and the slope. So you first go to the y-intercept. So if the y-intercept is -3, that means that my line crosses the y-axis at -1, -2, -3. So there's the y-intercept right there. Now, from that point, we're going to use our slope. And remember, our slope, another way to think of it is rise over run. So my rise is 5. So from my y-intercept, I'm going to rise up 1, 2, 3, 4, 5, but I don't stop there. My run is +3. So I go to the right 1, 2, 3, and I go to that point right there. That gives me 2 points, and that is a picture of my line. Notice my slope is +5/3. Notice how the line rises to the right, just like it should. How about B? Well, the first thing we would have to do is to convert this to slope-intercept form. This is not in slope-intercept form because the y is not totally alone. It really has a -1. So I can get rid of that by dividing every term by -1. So when I do that, I'm going to get y is equal to +4x and then -7. This is the line in slope-intercept form. So let's go ahead and let's use the method I just showed you, and let's graph this using the y-intercept first, which is -7. So on my graph, I'm going to go down to -7, and that's where I'm going to put my starting point. Now my slope is 4. That's the same as 4/1. Think of it with a rise and a run. So what I'm going to do from my starting point, my y-intercept, is I'm going to rise up 1, 2, 3, 4, and then I'm going to run 1 to the right. So you can see those 2 points, and you can go ahead and you can graph that line. All right, if we look at C, the last one, you can see that that's nowhere in slope-intercept form, not even close to slope-intercept form. So we have to go ahead and we have to solve this equation for y. So I want to get the y all alone. So the first thing I'm going to do is I'm going to subtract 7x from both sides. That's going to leave me with -2y is equal to, now notice in y equals mx plus b form, the thing with the x has to come first. So we're going to have the -7x first and then the +8. And then if I go ahead and if I divide everything by -2, that's going to give me y is equal to, now a negative divided by negative is going to be +7/2 x, and then 8 divided by -2 is -4. Here is my line in slope-intercept form. So now I can go ahead and graph it. What's my y-intercept? My y-intercept is -4, so on the y-axis from the origin, I'm going to go down 1, 2, 3, 4. There's my y-intercept. And then from that point, my rise is 7, so I'm going to go up 1, 2, 3, 4, 5, 6, 7, and I'm going to run +2 to the right, put my second point, and you can see that my line looks something like that. All right, we're going to stop this video and we're going to have a part 2.